Alright, so we will be going over the first module of the AI 900 exam course on Microsoft Learn, which is an Introduction to AI Concepts. Introduction to AI? This module provides a high-level introduction to artificial intelligence and its core capabilities. It is designed to help learners understand what AI can do and the basic principles behind it. This focus is on conceptual understanding rather than technical implementation, so it does not include coding or detailed mathematical explanations of machine learning models. The goal of the module is to build an intuitive understanding of how AI works and where it is commonly used. First section goes over generative AI and agents. Generative AI is the type of AI that creates new content such as text, images, video, or code. It works using language models trained on large datasets, often internet text, to learn patterns and relationships between words. Users interact with generative AI through prompts, which are natural language instructions or questions. The model processes the prompt and generates a response by predicting the most likely sequence of words based on what it learned during training. Language model types. We have large language models, which are trained on very large datasets, have many parameters, strong general knowledge, and are more expensive to train and run. Small language models are smaller datasets and models, more efficient and faster, and are often used for specific tasks or local/on-device AI. Some common use cases of generative AI include AI assistants and agents that help users complete tasks, content creation such as documents, emails, code, language translation, and document summarization or explanation. Key AI 900 takeaway. Generative AI uses trained language models and prompts to generate new content by predicting text patterns. Text in natural language. Natural language processing, or NLP, is an area of AI focused on enabling computers to understand and analyze human language. Natural language processing forms the foundation for generative AI and large language models. For many tasks, simpler NLP models can be more cost-effective than generative AI. Common NLP capabilities: text classification, assigns text to categories, includes sentiment analysis, positive, negative, or neutral. Key term extraction and entity detection, identifies important words or phrases, detects entities such as people, places, or organizations. Summarization reduces text length while preserving key points. Common use cases include analyzing documents, meetings, or call transcripts to identify topics and entities, evaluate sentiment in social media posts, reviews, or articles, and role-based or structured chatbots that answer FAQs without needing generative AI. Takeaway: NLP enables computers to analyze and understand language, supporting tasks like classification, entity recognition, sentiment analysis, and summarization. Next, we'll talk about speech. AI speech technologies allow users to interact with applications using spoken language. Core speech capabilities include speech recognition, speech to text, where AI detects and interprets spoken language and converts audio into written text, as well as speech synthesis, text to speech. AI generates spoken audio from text and converts the text into audible speech. Modern AI speech systems can also filter background noise, detect interruptions, and produce more natural-sounding voices. Common use cases include voice-enabled AI agents that understand and respond with speech, automated transcription of calls or meetings, audio narration for text or video content, and speech translation between languages. Key takeaway is that AI speech technology enables speech-to-text recognition and text-to-speech synthesis to support voice-based interaction with AI systems. Next, we'll be going over computer vision. Computer vision is a field of AI that enables systems to analyze and interpret visual data such as images, videos, or live camera feeds. Models are trained using large datasets of labeled images. Types of computer vision models include image classification, identifies the main subject of an image by assigning a label. Object detection detects specific objects and their location in an image, often using bounding boxes. Semantic segmentation, a more advanced form of detection that identifies the exact pixels belonging to an object. Multimodal models combine images and text to generate detailed descriptions of visual content. Some common use cases include AI agents that interpret visual input, image captioning or tag generation, visual search, retail inventory or automated checkout, security and surveillance systems, facial recognition for authentication, and robotics and self-driving vehicles. Key takeaway: computer vision enables AI to analyze images and video using techniques like image classification, object detection, and segmentation. Information extraction. Information extraction uses AI to identify and retrieve useful data from unstructured sources such as scanned documents, forms, images, audio, and video. A key technology used in document analysis is optical character recognition, which detects and extracts text from images or scanned documents. OCR is often combined with AI models that interpret, the extracted text and identify specific fields or values. More advanced AI models can now extract images from audio, images, and video, not just text-based documents. Use cases include automated document processing, for example expense forms and invoices, digitizing paper records for storage and analysis, document indexing for search systems, and extracting key points or action items from the meeting transcripts or recording. The key takeaway is that information extraction uses technologies like OCR and AI models to convert unstructured data into structured, usable information. Now we're going to discuss responsible AI, where responsible AI refers to developing and using AI systems in a way that is ethical, trustworthy, and aligned with human values. The core responsible AI principles include fairness. AI systems should avoid bias and discrimination by using carefully selected training data and fairness testing. Reliability and safety. AI models are probabilistic and not always correct, so systems must include safeguards and risk mitigation. Privacy and security. Training data and AI systems must protect personal and sensitive information. Inclusiveness. AI solutions should be accessible and usable by people of diverse abilities and background. Transparency. Organizations should explain how AI systems work and disclose their limitations. And accountability. Developers and organizations are responsible for the outcomes of their AI systems and should implement governance policies. Some examples of responsible AI include college admissions AI tested to prevent demographic bias, robotic vision systems using confidence thresholds to avoid unsafe actions, facial recognition systems deleting temporary personal images after use, speech AI with captions to support users with hearing impairments, AI loan approval systems disclosing the use of AI, and trading data characteristics. Takeaway is that responsible AI ensures that systems are fair, safe, secure, inclusive, transparent, and accountable. The hands-on exercise for this module, we explored a simple AI agent, Ask Andrew, this sample AI assistant, and Ask Andrew is a simple AI assistant, like I mentioned, used to demonstrate chat-based AI interactions. He uses a small language model that runs locally in the browser to answer questions about AI concepts. The exercise was designed to demonstrate how AI agents work and not how to build them. Some key features of the Ask Andrew agent include chat interface for asking AI-related questions, pointing text prompts and voice input, the ability to run in GPU mode, which is faster, or CPU mode, which is slower. And you have to keep in mind that responses may not always be accurate even when grounded in a knowledge base. So how Ask Andrew works, its architecture is that a user submits a prompt, the system extracts keywords from the prompt, those keywords are used to search a knowledge base. The agent then sends the model the system prompt, which is the instructions, the retrieved context, and the original user's question. The language model then generates a response and the agent returns the answer into the chat. An important AI concept is retrieval augmented generation, which is known as RAG. Ask Andrew's architecture follows the RAG pattern, where an AI system retrieves relevant information from a knowledge base, adds the context to the user prompt, and uses a language model to generate a response. What RAG does is it helps improve the accuracy and relevance of AI-generated answers. The key takeaway is that many AI agents use retrieval augmented generation, combining knowledge retrieval with language model generation to provide contextual responses. So the module assessment, first question, which is the most accurate description of generative AI, with the answer being generative AI uses a language model to create original content in response to a prompt. Question 2, what is an AI agent? An AI agent is an AI application that can perform tasks on behalf of a user. Question 3, an AI application reads email aloud to a user. Which AI speech capability is being used? And that is speech synthesis or text-to-speech. So in summary, this module introduced the fundamental capabilities of artificial intelligence and how they work. Key AI areas covered include generative AI and AI agents, systems that generate content and automate tasks, natural language processing, analyzing and understanding text, speech AI, converting speech to text and text to speech, computer vision, analyzing images and video, information extraction, extracting structured data from unstructured resources, and responsible AI, ensuring AI systems are fair, transparent, secure, and accountable. These capabilities represent common AI workloads used to build intelligent applications. And that was Module 1 in the AI 900 path on Microsoft Learn, where we discussed the introduction to AI concepts.